Hello, welcome to Wednesday night's homework. Like I promised in the handout, I'm just going to go through this quicker, partly because last night's was too long, and partly because school starts in 10 or 15 minutes. All right, so here we go. I'm going to assume you've read the question, and once again, black is going to be our work, and blue is going to be our notes. Although we're going to try to stick to the work in the interest of saving time. All right, item number one was sketching a slope field. This is what we did right before break. We're given kind of a representation of all the possible functions, and what we're going to do is draw the specific function that includes 0, 1, so that's going to be right there. And I apologize, my sensor on my pen is a little bit off, but we should be able to make do. And then once we plot, we just kind of use the field to go with the flow. So that feels like it flows pretty good. And like I said, my sensor is off a little bit. Really, I guess something like that would have been better, but I need to calibrate my... All right, hey, we just got 2 points. We used 0, 1, and we just kind of followed the waves. Next question. Here we're going to do another tangent line problem. It's going to be very similar to yesterday's homework in that our goal is to build us a linear equation. And in this course, we usually use slope-intercept. If you do point-slope, that's fine. Write an equation for the line tangent to the solution curve at 0, 1. So basically, whatever this line would be, that's our goal. We actually already know the y-intercept is going to be 0, 1. So that's actually... some free information. What we really need to know is the value to use for m, and that's going to come from our differential equation. So let's take 0, 1, because that's the moment, and plug it into our derivative, into our differential equation, because the job of the derivative is to calculate slope. So we'll have 3 minus 1 cosine of 0. And right, you do need to know a few of the basic sine and cosine values. This is going to be 2 times 1, which is going to be 2. Hey, let me give you some advice. If you can't remember if cosine 0 is 1 or 0, think about this. If this was 2 times 0, this would be 0. Which does this look like, a slope of 2 or a slope of 0? It looks like a slope of 2 to me. So we have our slope. We're going to just clear out a little bit of space. We've worked out our slope of 2. We're going to plug that into our linear equation. And honestly, we already know that the y-intercept is going to be 1. So right away, we can just put a plus 1 as our y-intercept. If this was some other kind of random point on the graph, you would plug it in for x and y and solve for b, but we got that for free. Now we're just going to use this equation to approximate f of 0.2. In other words, if you follow the line, what value are you likely to get? So in goes 0.2 is our x value. Let's not forget to add 1. And 2 times 0.2 is 0.4. We're going to add 1 to that. And what we got is f of 0.2 is approximately 1.4. So if you wrote like y equals 1.4, I'm sure you'll get credit for it. But this is a nice way of having the style of our answer fit the style of the question, both in terms of using the function notation, but also using the approximate symbol for the word approximate. But like I said, if you wrote 1.4, y equal 1.4, that would be fine. All right, let's hit the next question. Just go ahead and clear out some space. And the last thing we got to do is solve a differential equation. And that was the other thing we were working on before break. The idea of using antiderivatives and using an initial condition to create like the original function. So it says find the particular solution to f of 0 equals 1. In other words, that curve that we just drew, what is the actual function that makes that curve? So first thing we're going to do is take our differential equation and go through our routine. And if you don't immediately remember what to do, hopefully it comes back pretty quickly. We're going to take our y terms and group them with dy, and we're going to move dx and group it with cosine x. So this will be 1 over 3 minus y dy equals cosine x dx. At this point, we're now ready to integrate both sides now that each side is consolidated to one variable. On the right, we have sine x plus c. Don't forget your plus c. And on the left, we have what's going to be, okay, this is degree 1. So 1 over a degree 1 function uses the natural log. And we got to use absolute value. But don't forget, right, this isn't simply a y. It's a linear expression with a slope of -1. So you need to either divide by -1, or I guess the cleanest way to write that is just to put times -1, or put a negative in front of the natural log expression that I just mutilated. Okay, let's leave it like that. The next thing we want to do is solve for our c value, and we're going to use our initial condition. So we're going to have negative natural log, absolute value, 3 minus y, 3 minus 1 equals the sine of 0 plus c. Absolute value of 2 is 2, so this is negative natural log 2. And that's equal to the sine of 0, which is 0, plus c. So there we go. We have our c value. And I'm kind of skipping some steps so I can save some space. But I think all the big picture stuff is here. I tell you what, let's actually just draw over all this. Look at that. All right. So I believe we had negative natural log. We had 3 minus y in absolute value. On the right side, we had sine x. And we now have our c value, which is negative natural log of 2. At this point, we'll be done once we find y or we find f of x, right? You can use either notation. It looks like we're going to find y. The first thing we want to do is actually, let's just get rid of this negative. You don't have to get rid of it now, but I think now's a good time. Let's say natural log, absolute value 3 minus y. And on this side, let's just change our terms so that it's natural log 2 minus sine of x, right? Anytime you multiply a side by -1 or divide by -1, the effect is it changes the order of the terms. So like I said, I know I am skipping a little bit of the kind of algebra steps, but it should be pretty clear what's happening. We also now need to get rid of natural log, so that's going to be Catherine Avery maneuver. We're going to use E. These are going to undo each other, leaving us absolute value 3 minus y. And then on the right side, here, just like we can use plus to create some multiplication, we can use minus to create some division. So this is e to the natural log 2, which is going to be 2, divided by e to the sine x. Once again, I'm going to kind of clear this space out. And what we're going to do is have 2 in the numerator over here. And hopefully I remember how all of that went. I think it went something like this. Absolute value 3 minus y equals 2 over. And then we have e to the sine x. At this point, we need to drop the absolute value, so that is a Meredith-Alling maneuver. And what we need to decide is when we drop it, is it going to be a positive 2 or is it going to be a negative 2? So let's kind of, like I said, I wouldn't do this on the exam. The writer might find it confusing, the grader. But we are debating on plus or minus. So let's kind of see what happens. Imagine we plugged in our initial condition of 0, 1. And let's say we left it as plus. So we would have 3 minus 1 equals 2 over e to the sine of 0. Now, right away, we can see that the left side has a value of 2. So we need the right side to have a value of 2 as well. If we have negative 2 in the numerator, we're going to have negative 2 divided by e to the sine of 0. Since sine 0 is 0, e to the 0 is 1. I think 2 over 1 is going to be good. I think if we use a negative here, then we've got 2 equals negative 2. So like I said, almost all the time it's plus, because switching it to minus is kind of a cheeky maneuver that a lot of students don't really practice, or it's just kind of one thing too many to keep track of. So most of the time they use plus. But say 1 out of every 5, you actually have to choose the negative. We do not, so we're going to drop the absolute value. We are going to leave it as plus, and we're going to say it's that. Now at this point, we still need to solve for y. There's a few ways that we can do it. I kind of want to add y to this side and bring this entire term to the left, so that it's 3 minus 2 over e to the sine x. And then on the right side, we have equals y. And that's more or less our function right here. We could probably surmise that you could also maybe come up with a basic trigonometric graph, something like sine x plus 1 to create this. But apparently 3 minus 2 e to the sine x also does a good job of representing this curve. All right, I hope that came in a little bit quicker. It looks like I'm at 12 minutes. So that's last night's video in half. Once again, the first problem, slope field, plot your point, and then just ride the wave. Tangent line problem, remember tangent lines are always going for y equals mx plus b. Your slope always comes from your derivative, and your y-intercept comes from plugging in your original points, the points of tangency. Since this was a y-intercept, that step was really easy. And then the last thing we had to do was do one of those differential equations where we have 2 variables. So we split it into a y side and an x side and kind of integrate both sides, solve for our c value. All right, messy, 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 and we are done.